Hello everybody, welcome to another lesson by me, Miss Pythagoras. In this lesson I will explain how to sketch a more complicated cubic function. This is the third lesson of 6 on sketching a cubic function. Remember, you can also visit my website onlinemaths.co.za and find all the chapters in the grade 11 and 12 syllabi. The link is in the comments below. And if you haven't subscribed yet, please do that now. Back to the maths. So here I will explain more complicated examples on how to sketch a cubic function. Let's sketch the graph of g of x is equal to x plus 1 squared bracket 2 minus x. Now, in order for us to find out what the shape is, we need the value of a, the coefficient of x cubed. And in this case, it's not very clear. So what we first have to do is we will have to multiply out the brackets. Now, let's see. X plus 1 squared becomes x plus 1, x plus 1. And then I want to multiply out. So what I'm going to do is I'm going to put the 2 minus x in front. And then the two last brackets I will quickly FOIL out. And it becomes x squared plus 2x plus 1. Now, I will take the 2 and I will multiply it into all three. And I end with 2x squared plus 4x plus 2. And then the negative x I will multiply into all three. And I end with minus x cubed minus 2x squared minus x. Now I'm going to add my like terms. Nothing can add to minus x to the 3, but 2x squared minus 2x squared will cancel. Plus 4x minus x is 3x plus 2. So now it's very clear that a's value is negative, therefore this is a descending graph. The next thing is the x-intercept make y 0. Now, you are very lucky in this case since your work is already factorized. So don't try and factorize this one again. It's already there, the brackets are there. So you make y 0 and then your factors were x plus 1, 2 minus x, and you get x is negative 1 or x is negative 1 or 2 minus x is 0 and x is equal to 2. And by now you understand the fact that you get the same x value there twice, that means this is where your graph will bounce or hop. Y-intercept make x equal to 0. Now I'm using this one. You can use either of the two. So in x's place goes the 0 and the y-intercept is the point 0 and 2. We'll continue on the next slide. Sketch the graph of g of x is equal to x plus 1 squared bracket 2 minus x. So there on the right hand side, I kept that there for you just to show that when g of x is multiplied out, this is what you get. Because we're going to use this one. For the turning point, we know by now the derivative equal to 0. We'll take g of x, we'll take the one that's been multiplied out, because you remember with your rules of differentiation, you cannot differentiate if there's brackets. So let's find the first derivative, and we end with minus 3x squared plus 3, and we have to equate to 0. Remember, because a turning point is a local maximum or minimum. We can solve x, but first I will divide right through by negative 3, and I end with x squared minus 1 is 0. Now that one can factorize. It's the difference of two squares, and it becomes x minus 1, x plus 1 is equal to 0. And then x is equal to 1 or x is equal to negative 1. Now to find the corresponding y value, the rule substitute x is equal to 1 and x is equal to negative 1 into the original equation. I chose that part, the one that I multiplied out. Then in goes 1 in x's place, and I end with a 4. So the turning point is the point 1 and 4. And now when I substitute x is equal to negative 1, I'm hoping for a 0 there, because that is where the two x intercepts are, and remember that's where your graph will bouncy. So therefore, in x's place I substitute negative 1, and yes, I end with a 0. So the other turning point is the point negative 1 and 0. The last thing that I still need to work out is the point of inflection. And to find the point of inflection, it's the second derivative equal to 0. There's your equation. First derivative minus 3x squared plus 3. Second derivative minus 6x equals 0. And we can solve x. X is equal to 0. The corresponding y coordinate, substitute x is equal to 0 into the original equation. There's your original equation. In x's place, in goes 0, and I end with 2. Therefore, the point of inflection is the point 0 and 2. Then, on the right-hand side, there you'll see it flying in, the point of inflection 0, 2. Our graph will look like this. Let's see. The shape, it's a descending graph because a is smaller than 0. The x-intercept, the fact that we had the same number there, this is where the graph will hop or bounce, there at negative 1. Our other x-intercept is the point 2, 0. The y-intercept is the point 0, 2. And then our turning point, the point negative 1 and 0, that's where the graph hops, bounces. And then the other one, the other turning point is the point 1 and 4. And then our point of inflection is the point 0, 2. Remember, the point of inflection is where the graph's concavity changes. Now the next graph is a very important one, and I suggest you pay close attention and you memorize this one. The question is, sketch the graph of f of x is minus x to the 3 minus 1. So again, we'll start with the shape. A is smaller than 0 or negative, therefore it's a descending graph. X-intercept, make y 0. There's your equation. In y's place I substitute 0, and now I'm going to solve x. So what I will do, the minus x cubed will walk across and it becomes positive x cubed is equal to negative 1. And then you will take the cube root, and then x is equal to minus 1. So the coordinate there for your x-intercept is minus 1 and 0. Y-intercept, make x 0. In x's place, you substitute 0 and you end with the point 0 and negative 1. Then your turning point, derivative equal to 0. There's your equation. Let's find the derivative. It will become minus 3x squared, and I have to equate to 0. Derivative equals 0 for the turning point. Let's solve x. Minus 3x squared is equal to 0. X is 0. And then every x has an original y value, so into the original equation in x's place goes the 0, and I end with the turning point is the point 0 and negative 1, which is the same as the y-intercept, but that's 100% correct. Then for the point of inflection, there is only one stationary point. Therefore, this is also the point of inflection. Now we can sketch the graph. There's all the information, and your graph will look like that. Let's look at the graph closely. The shape A was smaller than 0, and there it's very clear that it's a descending graph. your x-intercept is the point -1 and 0, and your y-intercept is the point 0, -1, which is also your turning point, 0 and -1, which is also your point of inflection. So my advice to you is memorize this graph. I also want to show you this type of question where you still need to sketch the graph, but this is a level 3 question. Let's see. The cubic graph of f of x is equal to ax to the 3 plus bx squared plus cx plus d is defined by the following properties. And then they give you the properties, and then they say, by using the info, sketch a basic graph. Now, let's see. First of all, you have to interpret what the information is. Now, if you look at this, everything is equal to 0. So that means x-intercept make y 0. So f -2, 1, and 6, they are in fact your x-intercepts. They're at -2, at 1, and at 6. Why? Since the y is equal to 0. This notation, f of 0 is equal to 12. That means the x is 0 and the y is 12. In other words, y-intercept make x 0. So that point there translates to the y-intercept. And then the last bit of information that they give you there is that a is greater than 0. So a is positive. So now you must understand that this is the shape of the graph. So when you go to the graph, you will see that you will have to pass -2, you will have to cross 0 and 12, and then somewhere there your graph will turn, we don't know where. It has to pass 1, it has to pass 6. So there is a rough sketch of the information given. Now here's another one. The function f is defined by f of x is equal to ax cubed plus bx squared plus cx plus d. It has the following properties, and we have to sketch the graph. Now let's see. If 0 equals 32, this means the x is 0 and the y is 32. So this is the y-intercept, the point 0 and 32. The next one, where you find f of 4 equals 0. This means the y is 0, and then that is an x-intercept, make y 0. So there's an x-intercept at the point 4 and 0. The next one, f of -2 is equal to 0. Again, the y is 0, so that's an x-intercept there at -2. Then this one, the derivative 0 equals 32, the derivative means the turning point. So there's also a turning point at the point 0 and 32. That's a turning point. The other turning point is the derivative 4 is equal to 0. So that means there's another turning point at the point 0 and 4. The next one, second derivative, 2 and 16. This is a point 2 and 16, and the second derivative is the point of inflection. So there's a point of inflection at the point 2 and 16. Then this part means the derivative greater than 0. Now remember, the derivative means the gradient of the tangent to the function. Greater than 0 means positive. So there's a positive gradient of a tangent to your function where x is smaller than 0. Now go to the sketch. Smaller than 0 means to the left of 0. So somewhere there is a gradient of a tangent that looks like that, with a positive gradient, or because a positive gradient is doing that. Or x is greater than 4, so go to 4, to the right of 4 is greater than 4, there is the gradient of the tangent that has that shape. And then the last little bit, the derivative of x smaller than 0, that means the gradient of the tangent is negative, and that is a negative gradient. So where do we find the negative gradient? There, between 0 and 4. So go to the sketch. Between 0 and 4, the gradient of the tangent to the curve will slope to the left. Now, your graph will do this. It has to cross -2. It will cut and turn at 0 and 32. It has to pass the point of inflection, and there at the point 40, your graph will turn. Now you know how to sketch a more complicated cubic function. In the next lesson, I'm going to explain how to find the equation of the cubic function when 3 roots are given. Click on the video in the right-hand corner to take you straight to that lesson. This is Miss Pythagoras signing off till next time.